Nuclear power plants generate 14% of all electric energy in the world. In some countries even more, like in France, where over 75% of all electric energy comes from nuclear power. But where does the energy actually come from? There are two main nuclear reactions, fission and fusion. Fission is a process in which larger atoms split into smaller atoms and nucleons, while fusion is a process in which smaller atoms combine their nucleons into larger atoms. Those two reactions release large amounts of energy. But why? Let's first look on this. Imagine you have 4 small marbles, each of which weighs 1 gram. When you put all them together, the combined weight is 4 grams, what totally makes sense. But when 4 nucleons, for example 2 protons and 2 neutrons, form an atom together, in this case a helium atom, the combined mass of the nucleons separately is larger than the mass of the helium core. Although the nucleons are the same. How is that even possible? And where is the mass gone? This missing mass is known as the mass defect, and according to Einstein's famous equation E is equal to mc squared, we get the energy from the missing mass that was released when the atom core, the nucleus, was formed. The energy is released in form of radiation and kinetic energy of the core. Now to determine how much energy is released by a certain reaction, we have to simply look at the mass before the reaction and the mass after the reaction. If the combined mass after the reaction is less than before, the reaction releases energy. Otherwise, we have to add energy for the reaction to happen. Finally, the energy of the reaction is equal to the difference in mass before and after the reaction multiplied by c squared. So for the fission of one atom uranium, in average 200 mega electron volts are released. We can now see that the energy released by nuclear reactions is based on the mass defect according to Einstein's equation. If you enjoyed the video, please leave a like and don't forget to subscribe for more content on this channel. Have a nice day and bye.